Okay, so this is a video about section 1.4, which is the library of functions. So this is actually important, um, mostly for the results, although we'll go through the derivations, but basically we're going to be introducing a bunch of graphs that I expect you to basically memorize because they are going to come up all the time in this class and also in calculus class if you take that class. And so for each of these functions, we're going to plot at least 5 points to sketch the graph, and we're going to consider the domain and range appropriately, and as always, be sure to show a scale on the axis. Okay, so the first one is the cubic function, which is y equals x cubed. So if I don't know anything else, I'm just going to plot those same 3 points until I come into problems with them. I'm sorry, 5 points. I don't know why I said 3 points. Okay, so I'm going to have negative 2 cubed, which is negative 8, negative 1 cubed, 0 cubed, 1 cubed, and 2 cubed. And then I'm going to plot these points. Okay, so let's see. So I need to at least go up to like 8 and negative 8 on the axis for y. So that's like 8 and 4. Then I gotta have negative 4 and negative 8. And then I can have 1 and 2 on the x. Okay, so plotting my points. I'm able to sketch it. Let me sketch it in the highlighter because I can't make a very accurate graph anyway. So this is like kind of what y equals x cubed looks like. Okay, I want you to keep in mind the basic shape of it. All right, and this one, the domain and range is all real numbers, so there's no problem. The next function that we're going to look at is the square root of x. And I know that I can't take negative numbers in the square root, so I'm not going to have negatives. I'll start with 0 and 1. And then I'd like to have 2, but the square root of 2, I don't really know what that is, so I'm going to choose 4 instead, 9, and 16, just making things easier for me to compute. So the square root of 0 is 0, the square root of 1 is 1, the square root of 4 is 2, the square root of 9 is 3, and the square root of 16 is 4. So this time I need the scale on the x-axis to extend further out a little bit, and I don't actually need any negative numbers in for x. So let's let this be 16, 8, 12, 4, 2. And then on the y-axis, I only need to go up to 4, so I'll just count by ones. Okay, 1, 2, 3, 4. So I have 0, 0, 1, 1. I have 4, 2. I have 9, 3. And I have 16, 4. So if I was just making a rough sketch of what this function looks like, it looks like that. So this is the basic shape of the square root function. Please keep it in mind. And also, the domain and range is only values greater than or equal to 0. Okay, and then I think we've actually seen y equals x squared before. I think you guys will remember from one of the other videos. So it looks something like this. I have to put the scale and everything, but it's kind of showing you what you should be really understanding from this is just like the basic shape of what they look like. It's kind of like a U shape, which is also called a parabola. So I'll remind you of how we got that. Okay. This one, since y equals x squared, there's no restrictions on the domain. And then I plotted all these points. So basically this is like 0, 0. And then we will have like 1, 1, 1, and 2, 4, Okay, so something like this is basically how we got the graph of the function. So the basic shape again is just the kind of U shape or parabola shape for y equals x squared. Okay, and then the next one is the absolute value function. Again, I know that we've gone through this on the last video, so I won't spend too much time on plotting the points, and you can always pause the video and do the work, double check for yourself, right? So this one is kind of similar, but a little different because, for one thing, the scale is different on the x and the y-axis than it was for y equals x squared, and then also the absolute value of x is more like a v, and then the y equals x squared is more like a u, okay? And then also, like, you see how this one is a 4 and this one is a 2, so they're really not quite the same at all. Okay, so the next function in the library functions that I want you to be familiar with is the cube root function. So for the cube root, I can take the cube root of positive and negative numbers. It's different from the square root in that way. So I will choose negative values, but I'll choose ones that are easy to compute again. So I'm going to choose -8 because the cube root of -8 is -2. If you want to choose like other numbers and put it on your calculator, you can do that. I'm just choosing ones that I can do without a calculator. So the cube root of -1 is -1. The cube root of 0 is 0. The cube root of 1 is 1. And the cube root of 8 is 2. So I'll start with that. Okay. And so for my x-axis, I'm probably going to go out by 8. And then for the y-axis, I'll just count by ones. Okay, so I plot the points that I have. -1, -1, 0, 0, 1, 1, and 8, 2. And then I get the general shape of it. Again, just the general shape is like that. Okay, so this is what approximately the cube root of x graph looks like. And the domain and range is all real numbers. For part F, we're going to graph the identity function, y equals x. So this was like part of the absolute value function, but this one is y equals x all the way. So let me choose the same points that I like. So because y equals x, when x is -2, y is -2. Whatever x is equal to, y is equal to the same thing, okay? And so then when I go to sketch the graph, I'm also going to put the same scale for x and then for y. Okay, and then when I plot my points, like this part on that side looks like absolute value, but over here, it keeps going. And so when I make my sketch, I put that sketch of what it looks like, it's just this straight line. Okay, y equals absolute value of x. The identity function is a straight line. And then the last two can be just a little tricky, but we can figure it out. So for the reciprocal function y equals 1 over x, when we consider the domain, the only point that I can't put in it would be when the denominator is 0. So I can't plug in for x equals 0. But I'm going to plug in kind of like near x equals 0 just to be safe. So instead of 0, maybe I'll put like -1/2 and -1/10. And then I'm going to put 1/10 and 1/2. So because this one is like a little more complicated, I'll put a couple of more points just to make sure. So I'll still put 1 and 2. Okay, so when I put -2 in, I have 1 over -2. And then when I put negative 1 in, I have 1 over negative 1. And then the reciprocal of negative 1/2 is negative 2. And the reciprocal of negative 1/10 is negative 10. Okay, and then similarly for these, it's just that they're not negative. Okay, so I start to plot the points, and then let's see, how does it look like? So x, I did like that, and then for the what, really this is supposed to go all the way up to like 10. So let's just see. So this is just a sketch, but I'm going to plot negative 2, negative 1/2, so that's like pretty close here, and then negative 1, negative 1, and then negative 1/2, negative 2, and then negative 1/10, negative 10. And then I also have 1/10, 10, 1/2, 2, 1, 1, and 2, 1/2. So it might have been a little hard to see, but basically I'm ending up getting an interesting shape that looks sort of like this when I connect all the points. And then this is what the graph of y equals 1 over x looks like. I think you guys have actually seen this graph before, but maybe not known what the equation of it was. So the domain and range both exclude 0. And then the last example is the constant function, y equals b, where b is any real number. I guess I could do an example like b equals 2. It doesn't matter, but this is just to make it concrete. Okay, so this is x, and then y. So let me choose all of the points I want to plug in. And so what this is saying is that no matter what x equals, y always equals b. So in my example, y always equals 2. Okay, so then when I go to graph it, I have that no matter what x equals, y equals 2. And so basically what this looks like is a horizontal line at y equals b. So if b was like, you know, a different number, then the horizontal line would just be in a different place. Okay, so this is like a big review of graphing by plotting points. You always can attempt to do that, although like later in the semester we'll see much more complicated graphs, and I'll show you how to graph those ones as well. But also, I want you to basically like remember what all these graphs look like. So if I was like, oh, you know, x cubed, then you would be like, oh, I know, it looks like this, you know. So that's the end of section 1.4, Library of Functions.